We continue our discussion of job design and work measurement by looking at work measurement. Work measurement is defined as a process of job analysis with the objective of setting time standards. So why is it important? It is because, firstly, we need to have standards for scheduling and controlling our maintenance workforce. Secondly, it is used to motivate workers, very often through incentive bonuses for high productivity. Thirdly, it is used to control workers' individual outputs. And fourthly, it is an excellent benchmark of what constitutes good performance. Techniques of work measurement includes time study, work sampling, predetermined motion time data system or PMTDS, and determining standards from elemental time data. We are now expounding the first two of these four techniques further. First, time study. Time study is normally performed using a stopwatch, either timing work by direct observation of the task being performed or by timing the work from a video made for the purpose. The task is first divided into measurable elements, and then each of these elements is timed individually. Rules for dividing the task into elements. Short time elements but long enough to allow accurate timing. If equipment is involved, the action of the equipment should be separated from the action of the individual. Delays are separate elements and are timed separately. Here we have some equations used in time study. We define normal time for a task to be the observed time multiplied by a performance rating based on how many units of work the individual delivers, compared to what is regarded to be the standard performance. So the person timing the task should determine the time that the worker takes to do the work and must also evaluate the performance of the worker compared to a standard worker. The equation for normal time is the time as observed divided by the number of units produced times the performance rating. The standard time for performing the task is then defined as the normal time in which a productive worker will perform the task, plus a percentage allowance for personal time, that is such as lunch and toilet breaks and so forth. An alternative calculation of the normal time. Here we have an example of a time study of a 4-element job, which concerns assembling 24-inch by 36-inch chart blanks, whatever that is. The 4 work elements are fold over and grasp stapler, staple 5 times and drop stapler, bend and insert wire and drop pliers, and disposed of finish sheet and touch next sheet. In each case, 10 cycles observations are made of the times taken. Using the first element as example, the times are added up to 0.68 minutes for the 10 cycles, which are averaged to 0.07 minutes per cycle. The person's performance is rated at 0.9 of that of a fully productive person. This then gives the normal time for the elements as being 0.07 times 0.9, which is 0.063, truncated to 0.06 minutes. Adding up the normal times for the 4 elements gives a total normal time for the task of 0.55 minutes, see at the bottom. Combined with an allowance of 14.3%, which is a company standard, it then gives a standard time of 0.63 minutes for the task. In this case, the task of assembling one chart blank. Second, work sampling. Work sampling, also called activity sampling, deducts certain work content parameters from sampling a part of the activity. Work sampling can provide the following types of information. A ratio delay is used to deduct the ratio of time spent on a certain activity. This can be a person activity or a machine activity. An example is to estimate the percentage of time that a machine is idle. Secondly, use performance measurement to detect the performance level of a person or a group in relation to the standard performance. And thirdly, time standards or standard task times for the performance of a specific activity or task. The 5 steps of work sampling are the following. Choose the activities for which work sampling needs to be done. Secondly, estimate the proportion of time that the specific activity makes out of the total task. Thirdly, decide what the accuracy of the study needs to be. Fourthly, choose the time slot during which the study will be done. And lastly, after some sampling, recalculate the required sample size. Advantages of work sampling in comparison with time study includes the following. Firstly, one time study person can do a few time studies at the same time. Secondly, the observer does not need to be formally trained, except if the purpose is to develop exact time standards. Thirdly, timing devices are not necessary. And fourthly, long cycle time work can be performed with a relatively low time input of the observer. Fifthly, one observes the task over a longer time period, which minimizes the effect of the worker putting forward his best foot during the study. Sixthly, one can stop and start the study without negative effects. And seventhly, the probability of workers manipulating the outcome of the study are much lower. This then ends session 5B concerning work measurement.